And now let us introduce the third method of image features extraction. This method is based on K-mean clustering. Clustering means grouping data into clusters. Here, the clusters can be used to generate or create the image features. Each cluster has a centroid or center. The centers of the clusters can be used as features, or the number of data items or points in each cluster can be also used as an image features. Also, we can use the within clusters sums to generate the image features. Here we can use this method to create the features for any type of image, color image or gray image. The method is very simple and very easy to implement. Here are the steps of how to use this method to create the features extraction. First of all, we have to reshape the image matrix to one row. Then we select the number of clusters. For our case, in the image feature extraction, we use 4 clusters, but here in this example, we use 2 clusters. We initialize the centers of each cluster. The first cluster is the center is 16, the second is 22. Then some passes will be applied. In each pass, we have to find the distance from the point to the first cluster and the distance to the second cluster. We get the absolute value of these distances. Then we compare the two distances to find whether this point belongs to cluster 1 or cluster 2, depending on the comparison results. After that, we calculate the average of the points in each cluster. If set the new centers to these averages. If the centers changed, then this path will be repeated until the cluster's centroid cannot change. Yeah? Here is an example of how to do the calculation. It's very simple. The data item here, 15, 15, 16, and so on. Here the data item. Then we calculate the distant one. This is the distance from the point to the first center. The first center is here 16 and the second 22. 15 minus 16, the absolute value 1, 1, 0, and so on. Also, we calculate the distance 2. This is the distance from any point to the second center. The second center, or the center of the second cluster. Here we do the comparison. 1 with 7. This is 1 is less. So first distance is less, so this point will belong to cluster 1, cluster 1, cluster 1, 3 equal cluster 2, and so on. Here, after that, we calculate the average of the points belong to cluster 1. This is 15 plus 15 plus 16 divided by 3, and also we get the average of the points belong to cluster 2, and we set the centroids to the new averages. The first centroid will be 1530.33, the second 36.25. The centers are changed from 16 and 22 to these new values. So we move to pass 2. Pass 2 the same as pass 1. We have to calculate distant 1 and distant 2. Then we group the points according to distant 1 and distant 2. These points now will belong to cluster 1, and these points will belong to cluster 2. We find the average of the points in cluster 1 and the average of the points in cluster 2. This will be 18.56, 45.9. The clusters centroid are changed, so we have to move to pass 3. Pass 3, the same. We have to calculate distant 1, distant 2, and find whether the point belongs to cluster 1 or cluster 2, depending on the values of distant 1 and distant 2. Then we have to find the average. The average now is 19.50 and 47.89. There is a change, so we have to move to pass 4. The same thing will be repeated here. Find the average. Average is 19.50 and 47.89. No changes, so the new centroid will be for cluster 1 19.50 and for cluster 2 47.89. These points or these data items will belong to cluster 1. These data items will belong to cluster 2. We can use these centers as features, or we can use the sum of these data items, sum 1 and sum 2. This is the within cluster sums, or the number of points here in cluster 1 or cluster 2. In MATLAB, it's very simple to do the calculation. Here we have to get the image, then we have to reshape the size. We get the size. Tick-tock timer to calculate the features extraction time. We have to reshape the image to one row. Then we can use the K+means MATLAB function to find the centroid C or the within cluster sum D. Here we have to set the cluster numbers to 4 in order to get 4 features for each image. Here the centroid for the first image, 56, 108, and so on. Here the extraction time 29.68 second. The time is bigger than the time obtained in the previous methods, especially the modified local binary pattern method. Here, the centroid, we can use either the centroids as features or the within some clusters as features for a selected image. Here, for comparison, we use the same images. This is the features for image 1, image 2, image 3, and so on, image 10. The average extraction time is 1.202 seconds. If the image size greater, the time will be more. Also here we can see that the features are unique for each image. It cannot be repeated. So we can use these 4 values as a features vector for each image, and the features database will be a two-dimensional matrix with 4 rows, 1 row for each value, and 10 columns here in this example, because we use 10 images, 1 column for each image. Here, the second way of using K-means clustering, here we can use the within clusters sums. Also, the features for each image are unique and they cannot be repeated, so we can use them as an image primary key, or as a signature, or identifier, or classifier to retrieve or recognize the image in retrieval system or image recognition system. Thank you, and please subscribe and like, and we in the second video we will explain the 4th method. This is the method of image decomposition based on wavelet packet tree. Thank you again, and goodbye.